Okay, well, I'm just going to jump right into this because, as the name implies, it's a big state and there's a lot of water in here, and so I have a lot of information to cover. So, this slide right here is a slide that my division director shows to legislators when talking about the importance of the work that we do and just the sheer amount of water that is in the state. And while this is a point of pride for many, it's a point of pride for me too. When I look at this figure here of 11,000 inland lakes that are greater than 5 acres, it does give me a little bit of anxiety because I see this as 11,000 inland lakes in the state that have cyanobacteria to some degree. It's just a matter of whether it will reach bloom proportions or not. So way back when we first started recording citizen complaints about algal blooms in 2013, at that time we only got 9 citizen complaints that we recorded. Next year, that number jumped up quite a bit to 25 complaints, but then the big thing that happened in 2014, of course, was the Toledo water crisis. I probably don't have to get into any of the details of what happened there, but suffice it to say, this got the attention of the governor's office at the time because, well, Lake Erie touches Michigan, and so they were asking how much do we know about harmful algal blooms in Michigan, and the answer was not a lot. And so what happened was we got some increased funding for new equipment related to HABs, such as sensors with our sondes with phycocyanin sensors on them, Abraxas test strips. Our laboratory at Department of Human and Health and Services upgraded their facilities so that they could begin analyzing for cyanotoxins, and we gave out a couple of research grants to some universities. We also launched our email inbox, algaebloom@michigan.gov, that anybody can email if they have any concerns and think that they might have a harmful algal bloom by them. So a typical year of sampling looks sort of like this, where we typically have pre-planned sampling going on in inland lakes, whether it be for invasive species or TIMDAL development or nutrient analysis. And so the crews that go out on those trips, they know to look for cyanobacteria blooms and to collect a sample. If they see one, what's not as predictable is how many response lakes that we're going to go to, because those can be all over the place. And at first, it seemed like we could keep up with them, but eventually it got to be a situation like this where, they were happening spread out over a large geographic range and just became way too much for us in the Lansing Central office to keep up with. And so what we decided to do is take advantage of the fact that we have 9 district offices spread out throughout the state. And so starting in 2016, we supplied each district office with an Abraxas kit and trained them on what to look for as far as cyanobacteria blooms go and how to run the tests on the kits. And so this has worked out very well, because that way, if there's a bloom up here, it's much easier for someone in the Marquette district to travel just an hour or two to grab a sample out here, as opposed to somebody going up there all the way from Lansing. So as far as sampling goes, most of the time with the responses, they're on such short notice that boats might not be available to us, and so we end up doing shoreline sampling, which isn't too bad, because that's typically where the scums are going to be anyway, is washed up along the shoreline. If we do get out on a boat, we'll sample in the center of the lake, and then also just take a tour around the shoreline and collect samples in any points of interest, such as beaches, recreation areas, and of course where we see a bloom. Also, something that we've been doing over the years is if we do see a scum sample that's accumulated along a shoreline, and there's a pretty clear demarcation of where the scum ends and begins versus the clear ambient water. What we'll do is we'll collect a sample here in the scum, and then we'll also collect a sample nearby in the ambient water and compare how much microcystin and other toxins are in those two samples. When we go out there, if we have a exosonde with us, they have phycocyanin sensors on them, so that way we can tell somebody right off the bat that, okay, yes, this is definitely cyanobacteria that we're seeing. You should definitely avoid it. We collect the sample, run the Abraxas test strips on them. If the strip indicates that microcystin is present, or we have reason to believe that other toxins such as cylindrospermopsin or anatoxin might be present, then it will go to our laboratory and get run through a mass spectrometer. Right now, the laboratory is capable of running analysis on 10 different microcystin congeners, nodularin, cylindrospermopsin, and anatoxin A. And then those results get communicated to other partners in the state, and then the results get communicated to the appropriate county health departments. And so this is a good time to mention that it's up to the county health departments what actions they want to take beyond that, whether it be posting up signs around the affected water body, or some of them will release media releases to warn the public about harmful algal bloom that's occurring. So as the years have rolled on, we've continued to keep track of the number of water bodies with confirmed cyanobacteria blooms in them. As you can see, they've increased over the years. I went through and I looked to see how many responses we've made, and it turns out of all the blooms that have occurred, we've made it out to 77% of the water bodies. So that's 77% of these water bodies have been visited by an Eagle employee, and a water sample was collected. And the ones that weren't visited, those are cases where, believe it or not, sometimes in the middle of the winter, we may receive an email from somebody with photographs that they took last August or September of a definite cyanobacteria bloom, and they'll just tell us, hey, I thought you'd like to know about this. Other times, you know, we do get busy, and it might be 2 or 3 days until anyone can get out and collect a sample. And so if it's a delay like that, then we'll call the complainant up and ask, is it still there? So basically, is it worth us going out there? And if they say, no, it's all cleared up now, then a lot of times we won't end up going out there. Looking at where in the state the blooms have occurred, as you can see, mostly the southern half of the Lower Peninsula is where we see the most of these blooms, less in the northern Lower Peninsula, and a handful in the Upper Peninsula. It is a significant relationship, so there's an inverse relationship between the county centroid latitude and the number of blooms that have occurred. So not too surprising, the southern half of the Lower Peninsula is the most populated area of the state, also most agriculture there. And also, you probably noticed that I color-coded the points based on what type of lake we've seen these blooms in, and so whether they're excavated lakes, natural lakes, or a natural lake with a dam at the outlet, or reservoirs, reservoir being what was once a flowing river that was impounded in order to create a lake environment. And as you can see here, over half of the lakes that have had these blooms were either reservoirs or natural lakes with dams at their outlet. Why this is significant is because of these 11,000 lakes that I mentioned earlier, only about 11%, give or take, would fall into this category out of all those lakes. So as far as blooms go, reservoirs and natural lakes with dams at their outlets are then overrepresented as far as bloom occurrence. Going into why that is, looking at depths of these lake types, the reservoirs are shallower than your natural lakes and natural lakes with dams. Looking at shoreline development factor, which is basically just it's a measurement of shoreline irregularity. And so if a lake is perfectly circular like this one, it's going to have a shoreline development factor of 1. But as the lake, as they become developed or impounded and they have more shoreline compared to the area of the lake, the shoreline development factor will increase. And so this particular lake right here has a shoreline development factor of 5, and it's because it's got a small water body compared to the amount of shoreline around it. And comparing shoreline development factors among lake types, the reservoirs do have higher shoreline development factors. And so the other thing with the reservoirs too is that they also tend to have larger catchment areas, so just larger watersheds that are going to drain the nutrients into that, as opposed to the lake that I showed on the left. It's going to have a much smaller watershed. Also, these types of lakes, as you can see, tend to be highly developed as well, and also just when you get these coves in these irregular lakes like that, those small coves, they tend to be shallow, they tend to stagnate, and they get warm, and all of which is a perfect recipe for a cyanobacteria bloom. Going into the scum versus ambient water sampling, we did see more microcystin in the scum samples versus the ambient sample. Here you can barely even see the error bar. That this average of 1.6 micrograms per liter of microcystin in the ambient sample, as opposed to an average of 600 something for the scums. Lessons learned as far as algae complaints go. So you can see the number of algae blooms. Complaints has increased. It went through, and it turns out 52% of those complaints were actually about cyanobacteria. Although notice I put an asterisk there, and that's because when I'm talking about algae complaints in this graph, I'm only talking about green algae, diatoms, or cyanobacteria. I'm not talking about all of the complaints that we also get about duckweed, naturally occurring bacteria such as iron oxidizing bacteria, or just other strange stuff that comes my way. So this right here is actually an accumulation of insect exuvia that got sent to me. So I've had to adopt sort of a policy, if all possible, we ask that complainants send us pictures just so we're sure what it is that they're talking about. If it is somebody that's calling from a landline and there's no way that they can send us pictures, then we just ask them to describe as best as they can what it is that they're seeing, and we try not to put any ideas into their heads about what it is. We've also come out with a picture guide as well that's on our website to try to show people what cyanobacteria looks like, and also commonly mistaken material. Looking back at the program, one of the neat things that's happened recently is that Michigan State University recently did a study where they reached out to some residents who had previously interacted with us because they had cyanobacteria blooms on their lakes before. And just some of the highlights is here's a part of the survey where they looked at trust amongst the agencies, and we received high marks there. And in fact, the report said that participants were somewhat positive regarding organization responsible. And so given the political climate in the state, I'll take that as a win, that we're somewhat positively viewed. So looking forward, we are going to join the 21st century, and we're going to have an interactive HAB mapper. We've also began listing some of these water bodies as impaired because for not meeting their designated use for other indigenous aquatic life and wildlife, with phosphorus as the pollutant. So hopefully some total maximum daily loads will be developed, and maybe best management practices will be implemented. So in the meantime, we're just gonna keep on keeping on, but it's no longer just a solo effort amongst just me. We got plenty of help from all over the state. And with that, I'm going to turn this into an acknowledgement slide to thank everyone who's helped.